the geometric mean, GM. So in this lesson, we're going to look at geometric mean. If three numbers such as A, B, and C are consecutive terms, then the common ratio is found as follows. So, when A, B, and C are consecutive terms, A, B, C are terms of a GP, or a sequence that makes up a GP, or the three terms are geometric progression, then following the principle of common ratio, now give us second term over first term is equal to third term over second term. So which gives us this equation. So we're going to have B over A is equal to C over B. So when we cross multiply, we're going to have B times B equal to A times C, which is B squared equal to AC. If we take the square root of both sides, we're going to have B square root AC. So which implies that, so if three numbers such as A, B, and C are consecutive terms, then the common ratio is found as follows. B over A is equal to C over B, which implies that B squared is equal to AC. Thus, B is equal to the square root of AC, which is what we got here. Notice that the middle term, B, is the geometric mean. It follows that the geometric mean of two numbers is the positive square root of their products. For example, the geometric mean of 9 and 25, which is the third letter, is equal to square root of 9 times 25, which is equal to 3 times 15. So if we have 9 and 25, the geometric mean of these two numbers is 9, and so let's put it letter A between, or let's insert the geometric mean A between 9 and 25. This will give us 25. So if you follow this calculation, geometric mean will be the product, the square root of the product of 9 and 25. So A will give us square root of 9 times 25. A is equal to square root of 9 is 3, square root of 25 is 5, and A is equal to 15. So the geometric mean of two numbers is the positive square root of their products. Same principle applies to B here. The geometric mean of 49 and 6 over 1 over 4 is equal to the positive square root of the products of the two numbers, which is 49 times 6 over 1 over 4. 6 over 1 over 4 is 4 times 6, 24, plus 1, 25 over 4. And the product of the square root of 49 is 7, the square root of 25 is 5, and the square root of 4 is 2. So when you simplify, we're going to have 17 equal to 1 over 2. So bear in mind that the geometric mean of two numbers is the positive square root of the products of those two numbers. Solution. The third, fourth, and fifth terms of a GP are x plus 3, x plus 8, and x plus 18 respectively. Find x. So that's number one. The middle term, so let me write this sequence, the sequence x plus 3, x plus 8, and x plus 18. The middle term is the geometric mean. So x plus 8 is equal to square root x plus 3, x plus 18. So x plus 8 is equal to x plus 3 x times x squared plus 18x plus 3x plus 18 times 3, 54, so x squared plus 21x plus 54. So this will give us x squared plus 21x plus 54. Squaring both sides. X plus 8 squared is equal to square root x squared plus 21x plus 54 squared. So this will cancel this. So let's expand this. X plus 8 squared. X plus 8 squared is equal to x plus 8. X plus 8. So x times x squared plus 8x plus 8x plus 64. So x squared plus 16x plus 64. X squared plus 21x plus 54. So collecting like terms. X squared comes over minus x squared plus 16x minus 21x equal to 54 minus 64. So this will cancel. 16x minus 21x minus 5 and here minus 5x, and here 54 minus 64 minus 10. So x equal to minus 10 over minus 5, minus cancel out, minus 5 here 1, 5 here 2. Therefore x is equal to 2. So the value of x is 2. The number 2. Insert two geometric means between 12 and 34. Let the two geometric means be x, and y. Therefore the sequence is, therefore x and y. So the sequence is x. The sequence is 2. The sequence is 12 x, y, 0 to 4. So remember that this is GP. The sequence is a GP. So this implies that A is equal to 12, 1, 2, 3, 4, and C4 is equal to 3, 2, 4. So C4, AR raised to the power 3 is equal to 3, 2, 4. The first term is equal to 12. Equation 1, equation 2. So divide equation 1 by 2. So AR is power 3 over A 3 to 4 divided by 12. So AR is power 2 is equal to 27. So R is power 2 is equal to 3 raised to the power 3. Okay, so equating bases since powers are the same. Since the powers are the same. Okay, so R is equal to, therefore R is equal to 3. R is equal to 3. So common ratio is 3. Let's, okay, we've gotten R. So now second term C2, therefore C2 which is equal to x is equal to E is to R, but R is equal to 0. So C2 equal to R is equal to x is equal to E, which is 12 times 3. That's equal to 36. 36. C3 is equal to y. Give AR raised to the power 2, but R is equal to 3. So T is equal to Y is equal to 12 times 2 raised to the power 2, 12 times 9. One oh eight. So therefore the sequence is 12, 36, 108, 224. So therefore 36 and 108 are the two geometric means that were inserted into the AP. Insert two geometric means between 12 and 34. So these are the two geometric means that have been inserted into between 12 and 34 rather. I'm showing insert two geometric means between 4 and 108. So let the geometric means be M and N. So the sequence is 4 M N 108. So now we have the first term 4 and the fourth term equal to 108. So T4 AR is power 2 is equal to 108, equation 1, and E is equal to 4, equation 2. Divide equation 2 by equation 1. So A R is power 3, 108 over E over 4. So R is power 3, 108, 27. So R is power 3 is equal to 2 is power 3. So equating since the powers are equal, R is equal to 3. The next thing is to get first term. The next is to get the second term. So T2 is equal to M. That's equal to AR. But R is equal to 3. So A dot C2 to T2, which is equal to M is equal to first term 4 times 3. That's equal to 12. C3 A T3 is M. Therefore, the sequence is 4, 12, 36, and 108. 3B. Insert two geometric means between 1 over 32 and 1 over 256. The geometric means E, K, L. Hence the sequence is 1 over 32, K, L, 1 over 256. So A equal to 1 over 32, T C4 is equal to 1 over 256. So C4 AR is equal to 1 over 256, equation 1, and A is equal to 1 over 32, equation 2. Divide 2 by 1. A raised to power 2 is equal to 1 over 256, and divided by E, this is divided by 1 over 32. Here 1, so R raised to power 2 is equal to 1 over 256 times 32 over 1. So 32 here 1, 32 here 8. So R raised to power 2 is equal to 1 over 8. R raised to power 2 is equal to 1 over 2 raised to power 3. So equating bases, since the powers are equal, R is equal to 1 over 2. And T2 is equal to K is equal to ER, but R is equal to 1 over 2. So T2 is equal to K is equal to 1 over 32. 1 over 32 times 1 over 2. That's equal to 1 over 64. T3 is equal to E raised to power 2, but T3 is equal to L is equal to A raised to power 2, but R is equal to 1 over 2. So T3, which is equal to L, is equal to E 1 over 32, 1 over 2 raised to power 2, 1 over 32 times 1 over 4. That's equal to 4 times 32, 1 over 128. Therefore, the sequence is the first term 1 over 32, comma, T2, which is 1 over 64, comma, 1 over 128, comma, and 1 over 256. So 164 and 1 over 64 and 1 over 128 are the two geometric means inserted between 1 over 32 and 1 over 256.